Weathering, classification of weathering processes. After learning this lesson, you will be able to understand the meaning and definition of weathering. Know about the different types of weathering and characteristics. Understand the mechanism of different types of weathering processes with examples. Introduction. Weathering is a fundamental and dynamic process that plays a central role in geomorphological and pedological systems. From a geographical perspective, weathering is not only a mechanical or chemical breakdown of rock, but also an agent of landscape transformation, soil development and climatic interactions. It prepares rock materials for erosion, influences river sediment loads and governs the fertility of the soils across different climatic zones. Geographers are particularly interested in how weathering varies spatially and temporarily, responding to regional environmental controls such as climate, lithology, relief and biological activity. The process of weathering acts as the producer of regolith. An upper withered layer comprises solid rock particles which placed on unaltered massive hard rock. This unique arrangement gives a chance for formation of various landforms. Definition of weathering. From a geographical lens, weathering is studied in relation to climatic zones, soil forming processes, vegetation cover and human activities. It serves as a precursor to many other geomorphic processes and affects the sustainability of land use practices. Summified in 1991. General definition. Weathering is the disintegration and decomposition of the rocks and minerals at or near the earth's surface due to the exposure to the atmospheric agents such as water, air, temperature changes and biological organisms. Geological definition. In geology, weathering refers to the in situ mechanical breakdown and chemical alteration of rocks without the involvement of transport processes, distinguishing it from erosion. Pedological definition. In soil science, weathering is a vital process in the transformation of the parent material into soil, contributing minerals and altering textures and structure. In geographical definition, weathering is analyzed as a spatially variable process influencing landscape formation, soil development and regional ecological systems responding to climate and typographic variations. Geomorphological definition. In geomorphology, weathering is a fundamental process responsible for the initial weakening of rock masses, thereby facilitating erosion, mass wasting and long-term evolution of landforms. Definitions of weathering given by different geographers. According to Arthur Holmes, weathering is the mechanical disintegration and chemical decomposition of rocks at or near the earth's surface under atmospheric conditions. According to Staller, weathering is a group of processes whereby rock materials are changed in place by the disintegrating effects of atmospheric agents. According to Small and Withrick, Weathering refers to the breakdown and decay of rock in situ, that is, without movement, under the influence of atmospheric and biological processes. According to P. Dayal, weathering is a geomorphic process which includes both physical disintegration and chemical alteration of rocks and minerals at or near the Earth's surface, influenced by climatic, biological and anthropogenic factors. Classification of weathering process: the physical weathering, chemical weathering, biological weathering, anthropogenic weathering. Physical, mechanical weathering. Physical weathering, also known as mechanical weathering, refers to the disintegration of rocks into smaller particles without any change in their chemical structure. This process is driven primarily by environmental factors such as temperature fluctuations, pressure release, freeze-thaw cycles, abrasion and biological activity. It is especially effective in arid, semi-arid and cold climates where chemical weathering is limited. For example, in mountainous or polar regions, freeze-thaw action breaks rocks apart, while in deserts, thermal expansion and contraction due to the extreme temperature differences cause rocks to fracture. Wind, water and ice also contribute to the grinding and transportation of rock fragments. Over time, physical weathering plays a critical role in soil formation and landscape development. Freeze-thaw weathering, also known as frost action, is a mechanical weathering process prevalent in high altitude and high latitude regions where temperatures frequently oscillate around the freezing point. Water infiltrates cracks in rocks as the temperature falls below 0 degrees Celsius. It freezes and expands by approximately 9%, exerting significant pressure on the surrounding rock. This pressure gradually widens the cracks. Repeated freeze-thaw cycles eventually causes the rock to break apart into angular fragments. This process is instrumental in forming landforms like scree slopes and talus cones. It is a dominant agent of physical weathering in periglacial environments. Exfoliation, thermal expansion and contraction. Exfoliation, driven by thermal expansion and contraction, is a form of physical weathering common in arid and semi-arid regions with high diurnal temperature variations. During hot days, the outer layers of the rock expand while the cooler nights cause contraction. This repeated stress causes the outer layers to peel or flake off in sheets, a process known as exfoliation. Over time, this results in formation of dome-shaped landforms. Granite, due to its poor heat conductivity, is particularly susceptible. Geographical examples include exfoliation domes in central Rajasthan, India, and the famous half dome in Yosemite National Park, California. Salt weathering, holoclasty. Salt weathering or haloclasty occurs in arid and coastal environments where saline water enters rock pores through capillary action or direct contact. As the water evaporates, salts such as sodium chloride, gypsum or magnesium sulfate crystallizes within the rock. The growth of these crystals generates significant pressure, leading to granular disintegration and flaking of the rock surface. This process is intensified by repeated wetting and drying cycles. Typical landforms resulting from salt weathering include honeycombed rock surfaces and pitted stones. Geographical examples include desert pavements of the Thar Desert and the coastal cliffs of the Mediterranean.